So hello, my name is Naama Dayan, and I'm a graduate student in Ben-Gurion University in Israel, and my advisor is Professor Kobi Gal. I'm excited to present my work on intelligent recommendation in citizen science, since this is the first AI recommendation system deployed in citizen science domain. So citizen science engages people in scientific research. From astronomy to zoology, citizen scientists advance research by sharing and analyzing data, and through their contributions, learn new things and develop their skills. Here you can see an example of project in SciStarter. We collaborated with SciStarter, an amazing ecosystem with more than 3,000 global citizen science projects, where people can engage both in online and offline projects. To demonstrate what SciStarter is, here are examples of 3 popular projects in SciStarter. iNaturalist, in which users map and share observations of biodiversity across the globe. Kokoras, where volunteers share daily readings of precipitation, and stall catchers, where volunteers identify vessels in the brain as flowing or stalled. With thousands of projects listed in citizen science platforms, a main challenge can be finding the right project, one that really suits your needs and your interests. People come to the site with different motivations, and that's part of the reason why recommending projects to them is hard. The only thing SciStarter has right now is the search engine, but we know it doesn't work and people don't contribute to the project that it finds for them. Our goal is to create a smart recommendation system so participants can easily discover the projects most suitable for them. We hypothesize that by using AI, we will be able to give intelligent recommendation to people, and we are willing to test whether our recommendation system will result in better matches, increased engagement, and improved contributions as compared to SciStarter existing project finder. This is the GUI we built for this process, and I will now explain our methodology. Rather than ask people about their interests, we use the past interaction data in SciStarter to help the AI engine to recommend the best project, where interaction includes participation, contribution, and clicks they performed on SciStarter. Based on this data, we designed 4 different recommendation algorithms which are personalized for each user. The first algorithm is a naive baseline algorithm which recommends the most popular projects across all users. The second algorithm, called user-based collaborative filtering, is based on rating similarities between users. It ranks the project more highly for a target user if similar users to the target user have also contributed to the project. Another algorithm, called item-based collaborative filtering, is based on rating similarity between projects. It ranks a project more highly to a user if the project is similar to another project that the target user contributed to. The matrix factorization algorithm, SVD, directly predicts the relevance of a new project to a target user by modeling the user. In this sense, it differs from the others, which were based only on defining a similarity measure. It estimates the relevance of a target project for a user by maintaining a user model and a project model that include hidden variables that can affect how users choose items. We tested all these algorithms in an offline and online experiment, and here I'm going to focus on the online experiment, which is deployed today in the real world and is still running. Our online experiment included 131 users. These users were assigned equally into 5 cohorts: the 4 algorithms described before and the baseline algorithm, which recommends on SciStarter's promoted projects. We measure number of interactions with the project. This is the y-axis for users in the different cohorts. This is the x-axis. As we can see from this figure, all algorithms outperform the baseline algorithm, and SVD is the leading algorithm. In order to learn what is the user's opinion about the recommendations and the level of satisfaction, we conducted a survey with 138 SciStarter users. The survey included questions about users' overall satisfaction with the recommendation tool, as well as questions about the pattern of behavior before and after the recommendations. The majority of users, about 75%, were very satisfied with the recommendation tool and claimed that the recommendations were suitable for their personal interests and goals. This figure demonstrates the impact of the recommendations on the user's behavior. It shows that users who participate in the study try to recommend projects and contributed to more projects than before the study, where here you can see the experiment start date. This project has transformed how SciStarter helps projects recruit and support participants and better respond to their needs. It was so successful in increasing engagement that SciStarter has decided to make the widget a permanent feature on their site. This will help support deeper, sustained engagement to increase the collective intelligence capacity of projects. Thank you very much.
Thank you. Any questions from the audience? Yeah, very interesting work. And thank you again for attending the symposium.
Thank you.